Welcome to the Building Design Primetime Podcast, focused on providing valuable information for anyone looking to undertake a new build or extension project. We'll share our tips, tricks and stories from a building designer's perspective.
And welcome to the Building Design Primetime Podcast. I'm your host Amelia, and once again we've got Frank Geskus.
Hello everyone.
Yes, building designer extraordinaire.
Extraordinaire? Depends who you talk to.
Business mogul.
Oh, settle down.
And we've got a special guest here today. Toby, welcome.
Thank you very much. Thanks for having me. I'm excited to be here.
We're excited to have you. And today we're going to be talking about something that we don't talk about often, and often people don't think about this topic, but we're going to be talking about energy.
Yeah, Thermal Performance Assessors.
Correct.
Yes, that's how it's rightly termed. We call you the energy guys, the energy gurus, art of black magic with, why does this house work thermally really well and other ones don't?
The guy that produces the tick.
The big tick.
Okay.
Yeah, everything's all right. You're allowed to build that house.
Yeah, for sure. No, it's good. It's an interesting subject, and it's something that, like you say, we don't talk about too often. So it's nice to get together and maybe spread the word a little bit, give people a bit more insight into what we do and how we do it. And I suppose more importantly, why it's important.
And also the government's pushing very hard for it as well.
Certainly are.
And the national or the Australian building codes, they're pushing real hard. So how did you get started in it?
Well, I suppose like many people that started with thermal performance assessors, it was a very niche subject to start with. I started 15 odd years ago, a little bit longer maybe, and my father was a designer, and we sort of saw, I suppose, the writing on the wall with energy efficiency that it was starting to come into regulation. At the time we had 5-star assessments, and I thought, well, look, I think this is an area that we need to get into, and especially in Tasmania and Victoria, especially, it's an area that makes a big difference to your house. If you're in a...
Oh, we know it.
Whether
you wear 2 jumpers inside or wear none.
Correct. And then in the summer, it's a difference between you're sweating all the time and you're trying to get rid of layers.
It goes the other way.
The other way. So we saw a need for that starting to happen, and with the government sort of bringing in regulation around it, it made sense to start moving into it. But for me, it started as like you said earlier, Frank, a side hustle. Yeah. Something that I
think it's how we all started in a lot of ways, just a bit of side hustle.
I know, right? And I think it was like you say as well, it was a good business to start as a side hustle, because we could sort of dip our feet in it, have a go at it, learn it, understand it, and mainly do it of an evening and of a weekend and things like that. And at the start, we only had a handful of people that we did work for, and that over the years that progressed, I had a few changes in my work life that pushed me towards going into this more full time, to the point now where we're, like I say, we're 15 years down the track, and we've got 6 thermal assessors now, and a geothermal engineer, and
which is pretty wild. I can't wait to explain that one later.
and now we work for a lot of different building designers, architects. We see thousands of house plans, over the time, and really we see our job as not just being able to tick the box for regulation point of view, but really to try and educate people into understanding what we do, why it's important, and then how they can use that to their benefit. How they can build a better house that is thermally more comfortable year round, but also is cheaper to run, has a lot more health characteristics about it, so that it's a nicer place to be in, that you don't get stuffy and things like that are probably a little more subconscious but really important to the overall health of the house.
Yeah, and health of its occupants.
100%.
And when I talk about thermal comfort, especially I know with my wife, she very adamant in getting the temperature just right in the house.
Yes.
Regardless of everyone else in the house.
Yes. Yep. I do laugh actually in the office because all of our regulation is built on 21 degrees.
Yes.
And I've found that 21 degrees isn't quite enough in the winter for most wives.
You're dead right there.
23 to 24 seems to be the comfortable
And that's why I'm in
spot.
shorts and a t-shirt in the middle of winter.
Yes.
You've
Yep.
obviously learned that happy wife, happy life does really fit the bill.
100%.
Oh,
yes.
Especially with thermal comfort. Definitely.
Yes.
Yep.
Very good.
Yep.
You've learnt very quickly and very well. Congratulations.
Oh, quickly, I don't know. I'm
not sure about quickly.
I've nearly been married for 29 years.
And you're still learning.
Yep.
Every damn day.
Yes. No, I'm with you with that one.
But at least I'm learning.
Well, that's good.
Maybe not listening, but I'm learning.
Speaking of learning, let's go back to the topic at hand. Toby, what about going back to the basics? What are the things that, clients that come in looking to build, say, a new house, what are the things that they can look at to improve their thermal efficiency?
Yeah, it's a good question. There's obviously a few simple things that we can all do to help that. And then from that point, I suppose, increasing complexity as it goes on. But the simple things are air tightness is really important for a house in general. And a lot of that comes down to the build quality. When we have the builder come in and they start to put things together, how they construct the house is really important. The design of the house is also really important. And that's something that we don't have control over, and we're not good at design, we're good at thermal assessing, but there is a vast difference between a really nice, well-designed house and a poorly designed house, and how that unfolds, I suppose, for the occupants themselves. Other than that, there's quite a few things that are starting to come on the market that can help with the overall health of the house. I think we were in a meeting just recently in Launceston with the guys that did the passive. I'm just trying to remember what it was called now.
Passive house?
No, not the passive house. We were talking about the ventilation systems.
Oh, the heat recovery ventilation.
Heat recovery ventilation, yeah. Right?
I'm a big fan of that.
Same. It's a fantastic product. It can help to heat and cool your house as well. It's inexpensive in relative terms to the whole house package, and we should probably put a link to that somewhere in the
Yeah, we'll be able to do that.
Podcast.
We'll have links on our website with our articles. So, yeah, 100% right. Depending how you do the heat recovery system, like I say, it can heat itself and you need minimal kilowatts in your, well, we use a lot of reverse cycle in the house. You can actually reduce it massively.
Oh, 100%. And it's a really, really good product, and I think that that's going to start growing in that space a lot. Other than that, and obviously with our simple terms of insulation and, the normal things that go into the house, really we start to lean very heavily upon windows. And windows, I sort of sound like a harping maniac sometimes about windows, but it really does come down to the performance of the windows, and the construction of those windows really does make a huge difference. Glass itself is very insulative, especially when we get to double glazing. Even just a generic double glazed unit rates really, really well on its own. It's only when we add the frame that we pull that performance down.
Because generic aluminium frames and the heat transfers
Correct.
really, really well.
Yep, exactly right. So it was a good way I've always explained it to people that have hard time sort of understanding the concept, is that if you stuck a steel poker in the fire, you could hold that for a certain amount of time and then you'd have to let it go. If you had the same poker but it was timber and you stuck that in the fire, you can basically burn to nothing before you have to let it go. So that's the difference between that heat transfer And steel or aluminium in this case, most of the time, it transfers heat so fast that it makes a huge difference.
Yeah. And also, that's why you've got all these different types. You've got the thermal brakes. You've got 2 bits of aluminium with a thermal brake in the middle.
Correct.
You've got the timber aluminium.
Yes.
PVC.
Yep.
Fiberglass. I've seen some steel frames, but that's more for that architectural look inside the house.
Yeah, steel's really interesting, and steel actually rates quite well.
Does it really?
Surprisingly, yeah. And it's all to do with the frame thickness. So when we get a steel frame section, we can get down to 4 or 5 millimeters of steel that's showing around the edge, and they use like an angle, as the frame. Because of that small surface area, we don't get a lot of
because it's such a reduced surface area exposure. Yeah, right.
Yeah. So with an aluminium frame, you have a look at home if you're following along, you would notice that the frame on most aluminium windows is quite wide because aluminium is a softer metal, so it needs a little bit more robustness to hold it all together, and therefore that more surface area just transmits more heat or cool or whatever it might be. Yeah.
Sure. Yeah, I've always found that fascinating. But then you look at PVC windows and they're ginormous frames.
Yeah.
They're big and chunky.
Yep.
But that's that European design as well, and they can handle putting triple glaze in them.
Yes.
Where we haven't really gone triple glaze much in Australia.
Not yet, no.
Yeah, and I suppose that's going to come. It comes down to economics too, doesn't it?
I think you hit the nail on the head with especially when it comes to windows. We have some really large factories in Australia that pump out a lot of, pretty much the bulk of windows that are used, and they're predominantly aimed at aluminium, and they have been for a lot of years. So until we start to see that move to other alternatives, I think that it's hard for that ship to move, to turn around.
Very much. I remember when I built my first house nearly 20 years ago, and single glaze was it. If you can go double glaze, oh man, you're wealthy. And
so true.
I work my budget so I can get double glaze just in my living area because that's where most of the heat loss was. And I was able to afford that at the time, and I thought, wow. And now it's just common as, but it did make a massive difference.
Yeah,
it was crazy. And you go to different parts of the house, you can actually feel the difference. But on really cold nights, standing next to the window, it's the frame. You can feel the coldness of the frame.
Yeah, it's amazing, isn't it? And it's a cool experiment to do if you're at home. Where you can just put your hand close to it, and you'll feel that cold air starting to pour off it. Yeah. Or
if you get those -4 nights or something, we were getting condensation on the inside of our frames.
Yes. Yep. And that's another really big issue, especially in Tassie. Condensation.
Oh, huge.
A lot of people deal with it every year still, whether it be an old home and a lot of new homes still suffer condensation issues. And there are some things that we can do to help that. We might actually talk about that for a second if you like.
Yeah, go for it.
Well, right.
It's kind of the buzzword at the moment in our whole industry because I've got
so many people struggle with this.
Builders are crapping themselves, to be honest with it, because they've seen the videos of people's houses where the condensation's ruined the house, yet they've built it as per the specs and as per the building code.
I know. And look, it takes me back to a couple of years ago when probably 4 years now, it always feels like 2 years, but it'll be longer. I was called to have a look at this house. The occupants had been quite ill. They'd been in and out of hospital, and they had a really bad condensation issue. And the builder had actually been taken to court over the build, and the occupants had won. And I was going in afterwards to help try and work out the condensation issue in the house. And what it did for me was it really landed home how important this condensation issue really is. There were a family of 4, and sure enough, they were still ill when I was there. They had black mould on the ceilings. The windows were just pouring water off them, and it was in a really bad way. And the occupants were in a really bad way as well. And so for me, walking into that situation, I didn't have anything to do with the building before that. We were just sort of there to try and help come to a conclusion or a solution. And there was a series of things that we found during that process that helped fix that house. That house, we got condensation free in 3 months. It took a lot of drying. It took a lot of, extra work, a lot of fanning.
A lot of testing too.
A lot of testing, yep. And even to the point the ceilings had dropped in 2 of the rooms.
Yeah.
They got the bats in the ceiling were so heavy it actually dropped the ceiling.
Yeah, I've seen the same thing, and the nails are just pushing through the plastic because they've got so wet and the sheer weight of it.
It's kind of scary,
Oh, crazy.
It's
the mould that's the scariest thing.
Yeah, that black mould, like it doesn't even look that intrusive, but what it does to the air and to the occupants with their lungs, it's terrible.
Yes.
So we ended up fixing that, but what that process sort of showed for us was just how important the condensation issue is in a real term, because we talk about it a lot, when we're talking about condensation management on plans, we talk about it in our ratings, it comes up, but when you attach it to a real world scenario, it starts to, I suppose, have more meaning.
It hits home really hard, especially when people become sick.
Yeah, definitely.
You can't understand the pain they're going through.
No, and for a long time they didn't know what was making them sick either. So they were doctors and trying to work it out, and they're telling me this story about how this process that they've gone through, and then they realised that it was actually the house making them sick, And one of the major issues, especially in houses built, I suppose, up to 2010, so you call it semi-modern homes.
Yeah.
Is the introduction to air conditioners.
Yes.
Or reverse cycle air conditioners. That has really caused such an exponential rise in our issues with condensation. And it's mostly because we get to winter in Tasmania, everyone closes their doors, they close their windows, and they turn their AC on to heat the area. And all we're really doing is just recycling air. It's going in, coming back out. And if we don't ever purge the air out of the building or clean the air, then all we're doing is just recycling
dirty air.
Right? That dirty air starts to get condensation or moisture.
Humidity levels, the moisture in the air increases over time. I
read somewhere that when we sleep, on average, we let out about 5 litres of water into the air per human per night, which is like a crazy amount.
That sounds disgusting. If I'm honest, it's awful.
Let's not go there any further.
We'll just touch on it. We'll keep moving. But that moisture has to go somewhere, and if we're not removing that on purpose, or we're not dealing with that issue, then all we're doing is we're just cycling it around.
So you keep breathing in the dirty air with the moisture that's come from you, and you're sucking it straight in. Sounds delightful.
So the moral of the story is to open your windows.
It is, and it that's one of the such a simple thing, and we call it purging. And these particular people, when we worked with them, we put them on a purge schedule, so that we made sure that they were opening and closing all of the windows in the house at least twice a day. And that's probably slightly excessive, because they had a larger problem. But in general terms, trying to cycle that air and getting it moving, is really important. Because the other thing that's happening as well that's working against us is that at the moment we're tightening buildings up.
Yeah, bushfire regs and all that. Yeah.
Right? So everywhere we're getting this air tightness, and we're getting it controlled more and more and more, which is great, because the more we can control our internal environment, the better we can heat and cool it and things like that. But if we don't have in mind that we need to deal with that air properly, then we cause ourselves problems.
Oh, 100%. Yeah. I lived at my very first house was about 100 years old. Wonderful, 14-foot ceilings, doors with huge gaps, the windows that rattled at night and all the rest of it. And going to sleep, and you could see yourself breathing. It's like, I gotta love Tasmanian winters when these old joints with no insulation.
But that building would have leaked so much
Yeah, we never had a problem.
Correct, right?
But, you know, when we started our first kid, you know, you want to keep
Yep.
the room warm and all
Yes.
that, and, you know, croup and all that, so you got steamers going, all sorts
Yep.
of stuff like that.
Yep.
Yet the buildings were able to, it got rid of the moisture.
Yeah. Oh, and back then too, you probably had a wood fire.
Oh, yeah, monster one.
Okay.
Yeah.
So you crank up the wood fire, it heats the air, and it literally just burns most things out. Then you've got lots of leakage, so that air gets circulated, right? Which means you've got to start your wood fire up early in the morning because
Yes.
it's cold again.
Yeah.
But that process actually kept us a pretty healthy home.
Yeah,
and-
people don't look at it that way, do they?
No, it's an
It's really interesting
concept.
how wood heaters perceive. Wood heaters are starting to get a bit more popularity here again, like pellet heaters and stuff
Yep.
too. Yeah, so it's interesting. I never thought of the fire actually burning up the moisture.
Yeah, and so with the new version of wood fires, we'll call them, there's quite a lot of different things now that you can get that help this process, such as insulated flues, vents that let air in, so that because the wood fire, for it to actually burn, needs a lot of oxygen to go into it, so it can draw that air, heat it up, and we can use it. And that process is actually quite healthy for us. You know, it's a good way of producing heat. Now,
It's a lot more work than just pressing a button, mate.
certainly a lot more work.
Well, I'm pressing a button because I went from that to a brand new home. Press a button, it's happy days.
Yeah, I know. Well, I can turn mine on with my phone, right?
Yeah, I know. And we love this convenience. Forget about putting it on the fire. It's too much work.
So true. My house still leaks pretty badly, so it's healthy. But it's, I suppose, when we're starting to move into this new condensation phase, I suppose, because like government's right onto it at the moment. I had a meeting with the government late last year, and I was talking to them about 7-star because Tasmania is not taking on 7-star anymore.
And that's partly due to the condensation
Correct.
regs aren't resolved.
Yeah, so they said that their biggest concern right now is that we're still building homes that can have condensation, and it's not every home, and that's the thing that they're most worried about, because they're saying, well, okay, we're building them very similar, but some have the problems, some don't. Why is that? So the University of Tas has been engaged for another condensation study.
Another one.
Another
They'd be loving that, wouldn't they? What is that, 3?
keeps them moving.
Yeah. Hope it's a bit more specific now. Because the guys there did a great job on the last one.
Yes.
It was great. So hopefully that expands on that study.
Yeah, so I dug into it, I tried to dig into it a little bit because they're quite guarded with what they talk about. A little political.
Oh, really? I couldn't imagine that.
Who would have thought? But they've sort of said that they would like to have, out of this next study, more construction detail. So the last one was more about conceptual things, what we should and shouldn't do and what we're trying to minimise and things like that.
And to be fair, it was good because it made us educate us a bit more.
Correct.
On that. And everyone's talking about it in the industry. And that's good. I think that's where it has to be, so we're aware.
Definitely.
But I had an instance today where they don't get, like, classic example, putting the isolation up in your roof. Having the gap to your roof sheeting.
Yep.
Not shoving it straight hard up against the roof sheeting.
Yes.
It says it's been fine for years, but the thing, our buildings have changed. The way we operate the buildings has changed.
Yep.
It says you cannot do it the old way anymore.
Yep.
You have to follow putting it under the batten or put a vented batten.
Vented, yeah.
A vented batten on top of the other batten.
That's right, yeah. And I think out of this next study, that's the idea, is to expand on those sort of details so that we have a better range of do's and don'ts, but more specific to say, okay, this is the particular roof, this is exactly how we do it, and we're just building on what we've already got.
Which is good. Has anyone studied the New Zealand standards? Because they've gone through a lot of this pain as well.
I feel like sometimes we should study that a bit more because
they've been through the same pain. In worse, they had a horror show, didn't they?
They did. They did, and they've done a lot of work.
Yeah.
And they've got their houses to a point now where they are quite healthy and that they're going well. So it's a bit of a journey that we're going on. Victoria's committed to 7-star. They're going to
as New South Wales.
As New South Wales, yes, and it'll be really interesting to see how that goes, because from our perspective, 7-star is quite a stretch from 6.
Because it's not a straight linear change; it's exponential.
Not. It's a bell curve.
Yeah, bell curve,
really, and it's a huge jump really from 6 to 7, and a lot of the buildings that we've been assessing over the last couple of years that meet 6, there's actually probably no way they'll get to 7. Exactly realistically.
Right. Yeah. It's going to be pretty challenging for some of them, especially the size and the types of houses that are being designed and the expectations of the clients. Because we all know that the bigger the house you build, the harder to meet that star rating.
Correct. So that's the other curve that happens, is that if you are doing a single bedroom unit, it might be in a multi-storey development, you'll get credits for that, which are done in the background. So you'll meet the minimum 6 or 7-star quite easily. But then as we build, we go to a single dwelling and we get bigger, it gets much harder to meet that standard. So.
And we've experienced that firsthand. It's or you've helped us with a couple of projects with some really
real challenging ones.
Some real challenging ones. And when we told them the type of windows we had to put in, and they were extraordinarily expensive in proportion to the house.
Yep.
Hence, then we went into performance solutions.
Yes.
Thank you so much for coming in today, Toby. We might wrap up part 1. And if you'd like to listen to part 2, stay tuned, everyone, because it will be coming to the airwaves very shortly. See you next time, guys.
You're listening to the Building Design Prime Time podcast.